My name is Duncan again. I'm the Director of Solutions Engineering for Vultr. We just recently partnered with Airtel to expand here into India with 3 data centers here in India, 27 globally, and look forward to kind of sharing a little bit of how we can change how we're doing software development to provide a better product for the developers that are out there. What I always like to do is talk about, where did we really start and what are we trying to accomplish? Because until, like Vinay in his presentation talked about, what are the goals that we're trying to get to? When we can define those goals ahead of time, it makes us a lot easier to make decisions about, what is the right path to take, what is the wrong path that's going to lead us the wrong way. In terms of the goals for these modern application architectures, we're not going to start with how. I think that kind of brings us too close. We're not going to talk languages. We're not going to talk frameworks. We're not going to talk what technology. Let's really figure out, how not to use the buzzwords that are there today. Because that way we can really focus on what are we trying to accomplish as developers? How are we trying to improve the experience that our users are having? So from a developer standpoint, we're going to look at 4 things pretty consistently. The first 2, I think of as very selfish analysis. Is it agile? Is it portable? In terms of agility, really talking about, I think Vinay illustrated it perfectly in the slide before, where it's all spaghetti code. That wasn't, 80 columns. That was probably 120 columns and, 50 rows worth of text all in a single query. How we've all been put on projects where someone's like, oh yeah, just go look at the code, and you look at the code and you're like, how drunk, how, impaired was the person who wrote this, and how does the machine actually execute this good enough that we have 1 bug, not 1,000 bugs that I'm trying to fix today. So in terms of that agility, being able to deliver an experience that as a software developer, you don't want to pull your own hair out at the end of every day. Second, portable. What is better than not having to do work because you did it right the first time? That you can take code you've already written, for a previous project, for a previous part of the pipeline, for another situation, and you can reapply that in this same way. So I think those, from a software developer side, very clearly, hey, this makes my life better. Now going from what I'm trying to do in front of my desk, in my laptop, in my IDE, to what the things that does the company want? We want something that's scalable. Great. You wrote an amazing application that we can get to work for 1 person at a time. If we can charge $1 billion at a time, we're in good shape. Most of us can't charge $1 billion for 1 application for 1 customer. We've got to find more customers and be able to scale this out in ways that can deliver this, not just locally, but more and more in a global fashion. And then lastly, resilient. At the end of the day, what opens Jira tickets when things break? What's the least productive thing I can do is fix bugs as opposed to write new features. So it's really a case of how do we build a code base that's resilient in that same way? Bugs are going to happen, they're a fact of life. But how are we capable of very easily maintaining it and making those fixes? Then on the other side, we want to keep in mind our users. It's great to make our lives easy, it's great to make our businesses scale and grow, but at the end of the day, customer delight, not just, it works well enough, this is less miserable than doing it by hand, my intern's gone for the semester, I can't give this to somebody else to do. Let's find ways to, how do we provide this for the customer and think about it from that perspective. These days in modern software, we're no longer living in a situation where you can write a code base in COBOL, in Fortran, and 60 years later still run it on the same IBM mainframe. We're expecting to deliver new versions, new features on a faster and faster pace. Not just because other people are doing it, but because we have interesting ideas that we want to put out into the world. Software features just aren't another way to spend a day so I can go home and, watch TV. It's, I'm trying to do something that's interesting so that I can share it with everybody else. Secondarily, back to that scalable, resilient idea from our perspective, customers are expected to be available these days. We don't live in a 9 to 5 Monday through Friday world anymore. If you tried to stream Netflix at 2 o'clock on Saturday night and it doesn't work, you're going to be just as angry if it didn't work on Wednesday at noon. It's a case where it's got to work all the time. And then lastly, connected. We're going to dive deeper into this We talk about, like Vinay said in his presentation, in terms of connecting pieces of data within one organization. Now, more and more people are expecting you to pull data from multiple sources to provide you a complete single pane of glass view. An example like this would be something like TripIt that I'm using to track my flight to go home tonight. I'm able to dump in, send an email into it that they've ingested, that they're now polling, flight availability information, so I know exactly where the plane that's taking me home tonight is right now. Pulling all of these different systems together enriches the experience that the customer takes care of. So we're going to talk about kind of a couple of different, a little bit of a history walk, and talk about, the challenges that we've seen, talk about how we can view using the kind of 7 things that I just covered and how they did and did not achieve those. And then we'll take a look at some other ways that we can move forward with this instead. So of course, we'll start off with, the classic punching bag in the room. We'll talk about that terrible monolithic application we've all had to maintain at some point in time, where everything is contained there. There's no breakout, there's nothing of separation, in terms of the user interface, there's no breakout of the data, there's no breakout of the process. All of these things are tied together. Like we just talked about, is this agile in any way, shape, or form, or is this back where you're staring at that whole entire dump of code, trying to figure out how one piece points to another? Is it portable? Can I ever reuse any of this for anything else? Like if we want to build another application where we're ingesting, doing the exact same function, is it easy to pull that out and use it again? We've all seen it where someone says to us, I can't take any more customers. The database is full. Whatever application level is choked. The servers don't get any bigger. Those scalability challenges that are inherent to this. And then definitely the resiliency. When one thing breaks, the typically massive parts of the entire operation break, not just, one single function impacting one single feature. So users kind of very much the same thing here. High availability is compromised. There's no ability to rapidly iterate and improve the solution. And then those connected interactions are incredibly difficult because you're essentially asking a monolithic environment to try to communicate outside in ways that it's not comfortable with. It doesn't understand how to make those conversations happen. So then, we've progressed forward. Thank God most of us who are working on something in terms of a modern infrastructure aren't stuck with monolithic applications anymore. We've taken a step forward with RESTful architectures. There have been some great benefits. Really separating the visual presentation, the user interface from the back end has definitely allowed those two teams at least to start interacting, not interacting less, but interacting independently. We can make changes to the front end, reskin what that visual looks like for the end user without having to change the underlying software layer. Vice versa, you can completely re-architect the underneath layer without having to change what happens on the front end. Those are just ways that you have the chance to communicate. But to this degree, so we've increased agility, we're able to go ahead and make changes much more easily. We're able to maintain code in an easier fashion. The code is more portable. Could you theoretically break down parts of these in ways that you couldn't before? Absolutely. Is it scalable? Is it resilient? We've added ways to do to bring those additional capabilities to the system. On the customer side, we are now able to improve the pace of deployment. We're able to improve things for our users, whether it's visual kind of paradigms change, who 10 years ago understood, whatever that little hamburger 3-line thing, in the corner of every website these days where I'm looking for anything and everything, it now drops down. It used to be 2 or 3 items. Now it drops down. It's like 8 different items. That was something that didn't exist, that you could iterate much more easily than before. We're able to make things more high availability because of how these different layers can now be separated out in a more distinct fashion. And lastly, connected interactions, because of the APIs that are utilized in a RESTful environment, there's starting to be the ability to, reach out and interact with an ecosystem as opposed to just internal systems. Customers, so we've made improvements, but realistically, what are the additional things that we can do? How can we bring more resources to the table? Everyone has, we all have wishes of, I wish I had 10 more developers. I wish I had 10 more data engineers. I wish I had 10 more infrastructure engineers. How do we use things that are outside in the ecosystem that already exist, that are well executed, well documented, and use their resources and their expertise as opposed to having to build that expertise internally? I'll give an example of a customer that I was talking to recently. They have a situation, like everyone these days, you're paying for your transaction, using a credit card. Being a relatively new company, they were challenged with the complexity of building a credit card fraud detection system. It's one of those cases where there's significant subject matter expertise these days somewhere else, whether it's because that business has existed for long enough where they've had to build this internally, or there's external systems that they can attach to do this same type of credit card fraud, credit card abuse type detection. Secondarily, how can we present to users on a different interface? We've all seen how weather has changed, and this past winter in the US on the West Coast in the Bay Area, it has just been raining left and right. I was chatting with one of my storage managers and just asked him, hey, having lived for almost 20 years in the same area, how has it been, for you? Has it been terrible? He's like, yeah, we had a power outage. The web browser, the display on my refrigerator doesn't work anymore. We've gone from having a desktop computer, a laptop computer, to a phone, to an Apple Watch that many of us wear, to now this guy's literally talking about he can access this stuff from his fridge and how he's having to replace his fridge because that doesn't work anymore. So being able to meet users where they are is an absolutely critical part of how we need to change the way that we move forward. And then lastly, actual work important stuff. How do we abstract out that business logic? How do we go ahead and increase that density and richness of the interactions of the ecosystem that are out there? Two concepts that I like to present to talk about in terms of embracing is really this concept of MACH, which stands for microservices, API first, cloud delivered, and headless, and the concept of composable, both from a software perspective as well as from a hardware infrastructure perspective. We'll deep dive a little bit of these and cover these topics here. So first, microservices, API first, cloud, native SaaS, and headless. For those who are not familiar with MACH, just want to give you an opportunity to see that. And then talking about microservices, I think most of us are familiar with them, in terms of something that we've either deployed or something that we've learned about previously. It's the ability to have each of these business capabilities that are individually created and maintained. So all of a sudden, I'm from the get-go stepping away from that monolithic design paradigm. We're definitely moving along, continuing along that path that RESTful architectures moved us onto. And then the fact that we can deploy them independently and have them much more granular allows for much greater definition of different changes in the system itself. We're gonna get to the point where all of these things are gonna be pretty repeated. On the left side, we're gonna talk about the benefits to the software side. We're gonna talk about on the right side the benefits for the users. Definitely a case of more agile and more portable. Once again, code maintainability becomes much easier to do because it's much more granular. In terms of the scalability and resilience, because now each of these microservices can be scaled individually, and because they're portable, you can take that thing that was written once, so let's use the credit card fraud example that I used previously. Service A can use that. As service A grows, it can be scaled independently, and as service B gets added onto the system and uses the same microservice, that can continue to be capacity planned for and scaled in the same way. This is kind of the realities of deploying software. We're all used to just writing the code and having it run. We also have to think about how do I go from my 1 or 2 test case to my initial proof of concept, 10,000 users, to my day 1 launch of 1 million, to hopefully something hyper successful. Imagine being the ChatGPT shopping cart developer. It's like it worked last Saturday to I did 1 million transactions today for people signing up for ChatGPT. So the second one then is API first. It's really the change of how software engineering gets done and how even these things get conceptualized from the very beginning. That you're dealing with this from the API, the schema, from the very initial thinking. How are we going to interface this with everything that's out there? whether that's on the front end in terms of how we're communicating different elements of that front end to the back end coordination in terms of how am I tying together, different services and different pieces of data on the back end. So I'm gonna, just for sake of time, I'm gonna let folks, run through this themselves, think about how you're able to deploy this in a more agile, portable, scalable, resilient way, and how does this help your customers as well. The third one then is really the concept of cloud native. I think this is something that, now that we're 15 years into kind of Amazon announcing, hey, we're gonna let you rent like these computers that we have, and you kind of think about it, you're like, yeah, you're kind of scaled up for like 6 weeks in the US, kind of 4 weeks around, Lunar New Year in Eastern Asia, a couple of other, big peak buying seasons, and you have all of this excess capacity. Wait, I can go ahead and use this on a basis that's much more economical than, building out my own infrastructure. So it's really a case here of all of a sudden, how do you take what 15 years ago was a pipe dream, not having buy pallets of servers for your worst day of the year, having to pay for them for the next 4 years because that's how finance is depreciating them, to actually being able to consume them, on a minute by minute, hour by hour, at worst case, month by month type scenario. With this really drives kind of two things, the scalability and the availability of what's happening. It allows us to grow in a way where we could never imagine before. We all remember 3 years ago when people were, scrambling to find whatever, commercial goods you couldn't get. There was video of the US of, markets with no paper towels and, all of those other things. Kind of from a compute perspective, for the most part, unless you're trying to buy GPU these days, it's about as available as you need. You need one server, fine. You need 1,000 servers, fine. You need 10,000 servers, no problem. We do a lot of HPC work with folks where that's exactly what they do. And then the last thing is headless. Back to the example of my storage manager and his refrigerator. How do you take the exact same application and show it in so many different ways? How do you provide interfaces that, in a computer screen, in a phone, on a watch, pulled from the exact same data sources, use the exact same code to run and illustrate the results. Nextly, in terms of the idea of composable, this is where I really want to start talking about the ecosystem that gets developed out there. It's really a case where no longer are you just looking for the resources you have internally. How do I leverage services that are available commercially, services that are available, on an open basis to design very rich software environments, very enriched experiences for my customers. So that's where really the rapid improvement piece happens, because no longer are you gated by the developers that are on your team. You can add in other resources from other parts of the world where you can add and bring in the talent that they can bring. So the part that my CMO kind of, make sure that I tack on to all of this is how do you combine all of this and what does it look like, okay? So like I said, in terms of a specific e-commerce setup, this is a pretty typical 3-tier application, design. But instead of taking a look at each layer as an individual piece that you're having to run, you can start thinking about each of these different things. So I'm assuming ERP, you're going to run, that's your data. Someone else's data doesn't really, matter too much. Same thing with finance. But each of these other things in the middle, whether it's the experience that the customer sees, how you're able from a commerce perspective, shopping carts, search, recommendation, all of those things that have really advanced in the last 5 years, execution, media, and then how do you deliver it in terms of that to the end customer. So those of us in the e-commerce space, we all, I didn't want to turn this into a NASCAR slide with 60, different vendors on this. Just think about how instead of having to take and write each of these components individually, you can go ahead and bring in other options that already exist in the marketplace. So how does Vultr enable, in partnership with Airtel here in India, developers to build this next generation e-commerce and web applications? It's really a case where we spent a lot of time talking about this microservices, API first, cloud delivered, headless strategy, because that's what we did. We went and built our business along those same lines because having a chance to look at how infrastructure and how software has matured, we wanted to make sure we put ourselves on a foundation that set ourselves up for success. So we ourselves as Vultr is a micro-based architecture. We are API first for how we talk to customers and how we orchestrate our own infrastructure. That cloud native infrastructure allows you to have that elasticity. You know, I care about Lunar New Year in East Asia, not so much in North America. I care about, you know, Black Friday, the day after Thanksgiving in the US, you know, Boxing Day in the UK and the other parts of the British Commonwealth. I'm able to scale demand on exactly where the region that my customers are. They're not having to travel halfway around the world to hit the database or to hit the web server so that they can, you know, try to buy the new PS5 drop or the new, you know, set of shoes that Nike just released. This allows us to deliver faster software updates for our customers. You know, the space that we're in, just like the space that you're in, is incredibly competitive. People are rolling out new features every day. And because of that, you want to make sure that you're able to keep up pace, not just keep up pace. I want to be an innovator. I want to bring things out to the marketplace that no one else has done before. How do I share that with folks without this ability to develop in this fashion? We want to allow our users to consume and orchestrate in that same fashion as well, because at the end of the day for us, it's not our workload. Yes, I care about our workload, but it's because we want your workload to work well. It's how we get those things to go hand in hand. So for those who don't know Vultr, just, you know, 2 seconds of that, you know, classic infrastructure as a service, cloud compute, cloud GPU, storage, bare metal, network, managed databases, and Kubernetes. I will put out this one thing because I know that there's probably some data scientists in the room. GPU is the hottest thing that we've all seen in the last 4 to 6 months, kind of as ChatGPT has really blown up, you know, people's understanding of large language models, you know, the benefits of machine learning. If you're interested in talking to us about that, we happen to have a couple of H100 servers still available, so please reach out. And then we have the ability to make this an easy deliverable. I think one of the biggest challenges for software developers and those working is how much time it takes to stand up your environment. You know, so we're looking for ways to speed that up to allow you to easily come on the platform and get your work done as quickly as possible. So by taking, you know, all of the different things that I talked about in terms of having that composable infrastructure, having that microservices-based API-first delivery of your internal software services, you're essentially able to kind of pick from the whole set of options and deliver that best-of-breed solution, as opposed to having to build everything in-house, instead of having to split your team up, as opposed to focusing on your business and what you do best. So want to just kind of run through the different options here. We talked about the infrastructure as a service layer that kind of underpins everything. You know, all of the DevOps, the MLOps, in terms of how you're building all of the different frameworks that you're choosing to use, how you can go ahead and increase the pace of the delivery of that. How these composable infrastructure services, you know, we're using these outside providers, how we're using, you know, someone to support a database, an outside object store, you know, how we're using network as a service providers to tie together, you know, disparate places, you know, we're using, you know, cloud orchestration software and open source software that was written by somebody else that we've continued to extend. And, you know, offering a managed Kubernetes offering to allow very easy portability of code from one environment to another. And then the composable SaaS services, you know, kind of back to that e-commerce diagram that I showed earlier, how you can pick exactly the pieces that you need to have to deliver your entire solution. So the benefits for everyone, you know, this is where you're maximizing the business, you're able to lower complexity and cost, and we're able to deliver this, you know, not just throughout India with Airtel's help, globally as your businesses continue to scale. So I wanted to say thank you very much.